Okay, let's talk about solving one-step equations. A solution to an equation is a value of the variable that makes the equation or sentence true. One famous method in one-step equations is what we call guess and check. Essentially, a solution is asking yourself, what number for x will make this true? So x plus 7. What number plus 7 equals 10? And a lot of people can solve this without knowing actual inverse operations, but that's what I want to show you right now. I want to show you how to solve one-step equations using an inverse operation. So first of all, I want to remind you what these words mean. Inverse, remember with your properties, those are the operations. Operations are your actions, your verbs in math, adding, subtracting, multiplying, dividing, and so forth. Inverse really means the opposite. So the opposite operation. So for example here, if I'm taking a number and adding 7, what would be the opposite of adding 7? It would be subtracting 7. And there's actually that inverse operation, or inverse property of addition says when you take a number and you add its opposite, you get 0. Okay? And it also tells you that x plus 0, any number plus 0, is just that number. That's your identity property. Okay, so before I continue, I want to kind of explain when I talk about an equation, here's what I want you to be picturing. Picture a balance beam scale. So have you ever seen these before? And if they're flat across on that little tip here, it means that the two sides are equal. So I'm always kind of drawing a line at the equal sign and imagining a left and right side of this equation, of this straight beam. So what we said here is that if I take a number and I add the opposite, so 7 minus 7, or 7 plus negative 7 means the same thing, I get 0. And if I take a number x and add 0, that just gives me x. Okay? Equals. Now, if I take 7 off the left side, I have to do the same here or else my scale is going to go like this. If I take 7 off, this just got lighter and my scale went like that, right? So to keep the two sides balanced, whatever I do to the left side, I do to the right side. And that would take it and straighten it back out. So I'm going to get here that x equals 10 minus 7 is 3. And there's an actual name of this property. Whatever I'm doing, really, whatever operation it is I'm doing when I'm solving an equation, that's the name of the property. So what did I do to both sides? I subtracted 7. So this is the subtraction property of equality. How do I keep the equation true? How do I keep it equal? Okay, and also if I go back to when I define solution, if x equals 3, if that's my solution, when I substitute that value back into the equation, it should make it true. So a lot of times what I'll do is I'll come off to the side and I'll do a little check. My original equation was x plus 7 equals 10, and I solved and I got that x is 3, so I'm going to substitute 3 here. 3 plus 7 equals 10, and 3 plus 7 is 10, and that's just my little check. I'm just verifying that 3 is in fact the solution. Okay, so let me show you the next example here. Alright, some number minus 3 equals 4. So I'm trying to figure out what y is. I'm trying to solve this equation. Okay, well, going back to our inverse operations, this is some number minus y. The opposite of minus, or the inverse operation, is adding. Okay, now remember, I've got this scale going on here, and whatever I do over here to the left, if I want to keep the left side and right side, if I want to keep this flat, I have to do the same thing to both sides. So if I'm going to add 3 to the left side, and I do that because I want to get 0 here, to keep this balanced, I add 3 to the right side. I might have called that right. Left side, right side. Okay, so I'm going to get on this side y plus 0. Your identity property says that that's just y. So y equals 4 plus 3, 7. Okay, what did I do to both sides of this equation? I added. So I've just used the addition property of equality. Okay, and I want to do a quick check here. I know it seems really silly when the problem is this simple, but I'm just trying to get you to practice all the skills, because when you get into 2-step, 3 steps, it starts to get tricky. And checking becomes a very important key, because if you know that it's not right, if you don't know that it's not right, you cannot fix the problem. And a lot of times students are able to fix the problem if they realize they have one. So I go back to my original equation when I check. Y minus 3 equals 4. Okay, I'm going to substitute what I got here. This is my solution I got. I got that y was 7. So I'm going to substitute 7 for y. 7 minus 3 equals 4. And I do this little math over here. I know these are quite simple, but I have now checked. The solution makes it true. So 7 made it true. Okay, next example. This says 8 times a number. So 8 times a number equals 24. So I want to do the inverse operation of multiplication. Remember, if there's no sign here, this means times. While the inverse or opposite of multiplication is division. Now remember, I've got my balance beam scale. I want to keep it balanced. If I divide this side by 7, I want to do the same thing to this side. Okay? So over here, what do I get? Again, I'm using the inverse property. This time I get 1. 8 divided by 8 is 1. Well, the identity property of multiplication says, okay, well, 1 times m, that's just m. Okay? So I've got my left side and right side here. 8 divided by 8, 1. 1m, m. Equals 24 divided by 8, 3. Oh, I'm picking up a pattern here. Okay, so if this is my solution, I'm now going to come over to the side and do a quick check. To do my check, I want to go back to the original equation, always the very beginning. 8m equals 24. My solution that I got here is that m equals 3. So if 3 is the solution, when I substitute it for the variable, I'll get something that's true. 8 times 3, 24. And on this side I just have 24, so I've checked it. Okay, what did I do to both sides? I divided, so I'm using the division property of equality. Alright, and my last example here, I can't put this paper up anymore. That works. Okay, so some number divided by 6 equals 5. So I've got my left side and right side here. To get k alone, so k divided by 6, the inverse or opposite of this division is multiplication. So if I do 6 divided by 6, that gives me 1. I got to keep my scale balanced, so I'm going to multiply this side by 6, always the same to both sides. And 5 times 6 is 30. So over here, 6 divided by 6 is 1. 1 times k, your identity property says that's just k. K equals 30. So again, if this is the correct solution, when I go back and substitute it into the original problem, it should make it true. So my original, we'll check here, my original problem was k divided by 6 equals 5. I got 30 for k. So if I do 30 divided by 6, I do in fact get 5. What did I do to both sides? I used multiplication. I multiplied. So this is the multiplication property of equality.